Welcome to our channel Sankalp Study Success. Today in this video we are going to learn about stochastic process. So this unit is completely depends maximum on theory part. So now let us see what is stochastic process. Here any variable whose value changes over time. That means there is let us consider an example of stock market where this stock market price will change overnight. So that means here if you consider this stock market as a variable, then the value of this variable changes over time in an uncertain way. That means it may be completely high or it may be completely low sometimes. So that means if you are changing a value of the variable in an uncertain way, then that process is known as stochastic process, where example you can take it as stock price. And also if you come mathematically, a stochastic process is set of random variables. You can denote it by xi or xf. So these depends on some real parameters like time t. That means just now we have learned that over time we are going to change the value of the variable. That means these variables depend on the parameter t. So it depends on parameter t, that is nothing but time. So this process, stochastic process, is also known as a random process because the values changes randomly. If you take the example of throwing a dice, if you throw a dice, you may get the numbers from 1, 2, 3 and so on up to 6. But these values you get it in a random way. So here if xn is the outcome of nth throw, where n is greater than or equals to 1, that means you are throwing the dice for n number of times. Then in the nth throw you are getting the value of xn. So this xn value can be any random value between 1 to 6. So this is one of the example for stochastic process or the random process. Now let us see what is state space. Here the values assumed by the random variable are called states. State is nothing but the value which you take for the variable. That is nothing but a state. Here the set of all possible values of an individual random variable, that is xn. In the previous example, if we consider throwing a dice, in the nth throw, the value of the dice you got in the nth throw is nothing but xn. So this xn is the set of possible values of an individual random variable of stochastic process. So you can denote it as xn such that n is greater than or equals to 1. So this is known as state space. You can denote this state space by using the symbol capital I. Using this capital I, we denote state space here. It is denoted by capital I. The state space is said to be discrete if you can count it. Discrete is nothing but a finite value. If you can count the number of values, state space is nothing but the values given to the variables. So if you can count the values, then you can say that space as a discrete one. If in case you cannot count the values, that means you are having infinite values, then you can say that your state space is continuous. So there are of two types, discrete and continuous. Coming to discrete, you can count the number of values. That means it is finite. Coming to continuous, it is infinite because you cannot count the number of values. So now, in the stochastic process, it is divided again into 4 types. So if we see here, the first one is continuous stochastic process. Second is the discrete stochastic process. Third one is deterministic stochastic process. And coming to the last one, which is non-deterministic stochastic process. So here, let us discuss one by one. Continuous stochastic process is nothing but we are having two variables, that is x and t. Because the x is nothing but the value of the variable and the t is nothing but the values which depends on the parameter t, right? So x and t are the two variables which we have. If both these variables are continuous, that means you cannot be able to count. You will be having infinite number of values. So if x comma t are both are continuous, then you can say that the given stochastic process is continuous stochastic process. Now, if in case x is discrete and t value is continuous, then your stochastic process will become discrete stochastic process. So if both are continuous, then it is a continuous stochastic process. But if x is discrete and t is continuous, then it becomes discrete stochastic process. And coming to the deterministic stochastic process, you can say a random process as a deterministic stochastic process if the future values can be predicted from the past observations. If you are having the past observations, by looking into that, you are going to predict the future values. That is deterministic. So exactly opposite to the deterministic stochastic process, you will be having non-deterministic, where by considering the past observations, you cannot predict the values of future values. So here, non-deterministic stochastic process is called, it is said to be if future values of any sample function cannot be predicted. Here it is cannot be predicted. In the deterministic, you can predict the future values by considering the past observations. So these are the four types of stochastic process which we have. Now coming to the next topic, probability distribution and density function. Here for any given time t1, we are considering, let it is a t1, the distribution function associated with the random process x1. That means the function x1 comma t1. This becomes probability of x at t1 which is less than or equals to x1. This equation is known as first order distribution function because there is only one variable which is x1. This is called first order distribution function, and if you need to find out the first order probability density function, then you are going to differentiate with respect to x1. That means fx of x1 comma t1 will be equal to d by dx1. That means we are differentiating with respect to x1. d by dx1 of capital F of x1 comma t1. That means we are differentiating the above equation with respect to x1 in order to find out the first order probability density function. Now, this is of first order because we are having only one variable. But if we have two variables, then we are going with second order probability function, and also if you differentiate this second order probability function with respect to x1 and x2, because there are two variables, so we are double differentiating it. That means differentiating with respect to x1 and also differentiating with respect to x2. Then you are going to get second order density function. Now, in the same way, if you continue the process, then you will get nth order joint probability distribution, nth order, which is equals to f capital F of x1, x2 and so on up to xn, comma t1, t2 and so on up to tn, because there are two variables x1 and t1 for the nth order. So we are considering from x1 and so on up to xn, and also t1 and so on up to tn. So then we are going to get this equation, and in order to find out the nth order probability density function, we are going to differentiate with respect to x1, x2 and so on up to xn. That means nth order differentiation we are going to do. Here, this is the nth order joint probability density function because there are n variables. That means from x1, x2 and so on up to xn. So we need to differentiate these many times. Then we are going to get nth order probability density function. So now let us see what is Markov process. Markov. This will be exactly similar to which we have learned just now, which is probability distribution and also the density function. Now let us see what is Markov process. Any random process which is stochastic process, that is also known as the Markov process. That means here P of x of Tn, which is equals to An by x of Tn minus 1. See, this is of only one term. And so on, if you consider for n minus 2, n minus 3 and so on up to 1, that means n minus 1, n minus 2, n minus 3 and so on, 3, 2 and 1. So in this way, if you take for all the variables, then you will get the Markov equation. This is nothing but the Markov process mathematically. Any random process or stochastic process, you can consider it as Markov process. So in order to define it mathematically, we use this equation, where for all t1 less than t2 less than t3 and so on up to less than tn, because each and every x term will depend on the parameter t. So this is the Markov sequence if the future behavior of the process depends only on the present value but not on the past. Here the value is depending only on the present value but not on the past. So this process is called Markov process. Now coming to the Markov chain. What is the Markov chain? Here xn such that n greater than 0. Xn such that n greater than or equal to 0. This stochastic process is called Markov chain. When will we call it? Is if P of xn is equals to an minus 1 xn minus 1 and also which is equal to an minus 2 xn minus 2 and also and so on. That means n minus 3 xn minus 3 up to x1 a1. Then that process is called as Markov chain. So these equations are important to remember, which is for the Markov process and also for the Markov chain. So here we are getting Pij. What is Pij? Which is nothing but the transition probability matrix. Transition probability, Pij. I nothing but it denotes rows, number of rows, and J denotes the number of columns. So now let us see what is transition probability matrix and how do we define that matrix. Now the transition probability matrix, it is denoted by Pij. Just now we have seen where I denotes the number of rows and J denotes the number of columns. You can denote it in this way or you can denote it by just capital P. And it will be arranged in the form of matrix, which is called transition probability matrix, and you can give as here this matrix consists of all non-negative values only. That means all positive values. And also for each and every row, if you sum the values of each and every row, then you will get the sum as 1. That means here we are having P11, P12, P13 and so on up to P1s, P21, P23, P33 and so on, P23 and so on up to P2s, PS1, PS2, PS3 and so on up to PSS. This is the transition probability matrix of order S by S. So here this becomes a transition probability matrix if all the elements present in this matrix are non-negative and also the sum of the first row. Let us consider the first row, P11 plus P12 plus and so on up to P1s. This sum should be equal to 1, and also the second row and so on like that. Sum of each and every row, sum of elements in each and every row should be equal to 1. So if these two conditions satisfy, then that matrix is known as transition probability matrix. So this is the most important one, and we are going to have some of the problems related to transition probability matrix as well. Now Coming to one step probability, transition probability, and also to the nth step transition probability. Now let us see what is one step, and then we are going to see what is nth step. Here in the one step transition probability, the condition probability P of xn is equals to aj or xn minus 1 is equals to ai. That means what? It is only the one step from xn to xn minus 1. So the probability from P of xn to P of xn minus 1. That means we are jumping from one state to another state by only one step. So this is known as one step transition probability, that is from state ai to aj. This is the probability and this is the state. So this is known as one step transition probability. And also coming to nth step transition probability, here we are not only going from xn to xn minus 1, we also go to xn to x0. That means n minus 1, n minus 2, and so on up to 0. That means we are going to have these many number of values in between n and 0. So it is an nth step transition probability. We are just jumping from xn to x0. So here the condition probability that the process is at aj, at stop n given that is in the state ai. So we are going from one state to another state, but it is a jump from xn to x0. That means we are jumping n number of steps. So that's the reason we are calling it as nth step transition probability, and we denote it as p to the power of n ij, or you can also denote it as pn. P suffix n can also be denoted, or p to the power of n. So these are nothing but the nth step probability transition probabilities. So these nth step transition probabilities are used in our problems which we do now. So if n is equals to 2 or if n is equals to 3, you can take any value. If n is equals to 5, then our transition probability will become p square ij if n is equals to 2. That means it is two-step transition. If in case n is equals to 10, then it becomes pij to the power of 10. That means it is a 10-step transition probability. So in this way we are going to define the number of steps. That means we are jumping from one step to the another step. So from xn to x0, which is nothing but nth step transition probability. So in this n, you can substitute any value where n is greater than or equals to 0. Now, let us see what is a stochastic matrix. Here, any square matrix. It is a square matrix. First of all, the first point is it is a square matrix. So, any square matrix is known as stochastic matrix when if all the entries are positive. Here the same conditions, all the entries should be positive and sum of the elements of each and every row should be equal to 1. Then if these two conditions satisfy, then that matrix is known as stochastic matrix. Now coming to the regular matrix, any stochastic matrix is said to be regular if the entries of the same power. That means if P is a matrix, then if you find p square or p cube or p to the power of 4 and so on, that means if you find the powers of p, then you should get all the positive values with non-zero. You should get all the entries should be positive. And the second point, which is the most important point to observe, that is one should not be one element 1 should not be there in the principal main diagonal. That means if you consider a 3 by 3 matrix, this is a 3 by 3 matrix where this is the principal diagonal. This principal diagonal should not consist of 1. That means you should not have 1 here, or you should not have 1 here, or you should not have 1 in this case. So if there is a 1, then it is known as an irregular matrix, and also you should have all the positive entries in the entire matrix. Then your matrix is known as a regular matrix. Now let us see some of the problems related to stochastic matrix. Here, the first question is, test the following matrices are stochastic or not. That means here we are given with a 3 by 3 matrix. First you need to write the given data which is the 3 by 3 matrix. Now in order to become a matrix as a stochastic matrix, you are having two conditions where all the elements which are in the matrix should be positive. So here if you observe in the matrix, each and every element is a positive number. That means it is a non-zero number. So the first condition is satisfied. Now sum of the elements in each and every row should be equal to 1. Now let us sum each and every row. That if you consider the first row, it is 0 plus 1 plus 0, which is equals to 1. If you consider the second row, 1 by 2 plus 1 by 6 plus 1 by 3. If you take the LCM, then you will get it as 3 plus 1 plus 2 by 6, which is equals to 6 by 6. That is nothing but 1. Now if you consider the last row, 1 by 3 plus 2 by 3 plus 0, which is equals to 3 by 3, which is equals to 1. So for this matrix, for the first matrix, sum of the elements in each and every row is equals to 1. So therefore given matrix is a stochastic matrix. In this way, we are going to solve the problem where we are going to write the given data, and we need to check whether each and every element present in the matrix is positive or not. And the second condition is sum of the elements in each and every row should be equals to 1. So now coming to the next one, let us solve this problem. Given data is equals to, which is a 2 by 2 matrix where all the elements are positive here. That means the first condition is satisfied. Now let us sum up the elements 5 by 16 and 1 by 16. This becomes 6 by 16, which is not equals to 1. So before summing up the second row, we have already concluded that it is not a stochastic matrix because sum of the elements is not equals to 1. So therefore we conclude that given matrix is not stochastic matrix because the condition is not satisfied where we are sum of each and every element in a row should be equals to 1. So now coming to the next question, the third matrix is also a 2 by 2 matrix. First let us write the given data, which is a 2 by 2 matrix. You need to write the given matrix as well. Now all the elements present in the matrix are positive elements. The first condition is satisfied. Now coming to the second condition, let us add the number of elements present in each and every row. If you consider the first row, it is 0 plus 1, which is equals to 1. And coming to the second row, it is 1 by 2 plus 1 by 2, again which is equal to 1. That means our second condition is satisfied. Therefore you can say that it is a stochastic matrix. It is stochastic. Now coming to the next fourth matrix, which is, let us write the given data again. Here all the elements present in the matrix are positive, so the first condition is already satisfied. Now let us add the number of elements in each and every row. If you consider the first row, it is 1 by 3 plus 2 by 3 plus 4 by 3. This is nothing but 7 by 3. 7 by 3 will never be equal to 1. That means therefore you can conclude that given matrix is not stochastic. So in this way, we are going to check whether the given matrix is stochastic or not by using two conditions. The first one is whether the each and every element present in the matrix is positive or not, and also the sum of elements in each and every row is equals to 1 or not. So if these two conditions satisfy, then you will conclude it as stochastic. If either any one of the condition does not satisfy, then you will conclude that the given matrix is not stochastic. Now let us go into one more question where three boys A, B, C are throwing a ball to each other. That means they are playing a ball game in which three persons A, B and C are throwing the ball to each other. Here, if A always throws ball to B, that means A is only throwing to B and B is only throwing to C. But let us write it here. A is only throwing to B and B is only throwing to C. If C is just as likely throw the ball to B and A, that means C is throwing the ball equally to A and B. So if C was the first person to throw the ball, then you need to find the probability that A has the ball, B has the ball and C has the ball after 3 throws. Now, what do we need to do? First step. In the first step, we need to consider transition probability matrix, because here we need to find the probability. So, if you take the transition probability matrix of A, B and C. So, here probability that ball is thrown from A to A. From A to A. Probability. This is nothing but 0, right? Because A is throwing the ball only to B. So, probability of A throwing a ball to B, which is equals to 1. Again, we need to consider probability of A throwing the ball to C, which is equals to 0. So, here, the first step we are taking only the A person. The probability of A throwing the ball to A is 0 and the probability of A throwing the ball to B is 1 and the probability of A throwing the ball to C is again 0. And now if you consider the person B, probability of B throwing to A, it is 0 because B is only throwing to C. And now probability of B throwing to B, B will never throw to himself, so again it is 0. Then probability of B throwing to C, which is equals to 1 because the ball is thrown from B to C, so the probability will become 1. Now if you consider the person C, C is throwing to A. See, we have C is throwing to A and B equally. That means the probability will become 1 by 2 and 1 by 2, right? So probability of C throwing to A will become 1 by 2 and probability of C throwing to B will again become 1 by 2. But the probability of C throwing to C, which is equals to 0 because C will never throw to himself. So here let us draw the transition probability matrix, which is equals to, we are going to draw in this way, which is 3 by 3 matrix because there are 3 persons playing the ball game. So ABC and ABC. It is nothing but the probability of A throwing to A. From these values we are going to fill the matrix, which is equal to 0. A to B is 1. A to C is again 0. Now B to C is only 1. The remaining is 0. And C is having 1 by 2 and 1 by 2 probability and C to C is again 0. Now we need to take the third step transition probability matrix because we need to take the probability after 3 rows. So this is nothing but P because it is a transition probability matrix. Now third step transition probability matrix. Third step transition probability matrix. So this becomes P to the power of 3. So if you take the value of P to the power of 3, then you will get it as 0.5, 0.5, 0, 0, 0.5 and 0.5. Then here 0.25, 0.25 and 0.5. This is nothing but the third step transition probability matrix. And here if the ball was thrown by C, here the question is C is the first person to throw the ball. So if ball is thrown by C, then let us write it here. If ball is thrown by C, so initial probability matrix will become P power 0, which is equals to, it is thrown by C. That means A and B will not have any probability and C will have only one probability, because C is the person who is throwing the ball to A and B. It may be to A or it may be to B. That doesn't matter. So our initial probability matrix will become 0, 0 and 1. So the question is, after 3 throws, that means we need to find the probability matrix of P power 0 into P cube, right? Because this is the initial probability matrix. If you multiply with the third step probability matrix, then you will get the probability of after 3 throws. So then it becomes 0, 0, 1. And here it is 0 0.5, 0 0.5, 0, 0, 0 0.5, 0 0.5. 0.25, 0.25 and 0.5. So if you multiply these two, then you will get the probability after 3 throws. That means P to the power of 0 into P cube, which will become 0.25, 0.25 and 0.5. So from this you can say that the probability of A has the ball is 0.25, right? Because this is for A, this is for B and this is for C. The question is, A has the ball, B has the ball and C has the ball. You need to find out the probability. So here probability of A has the ball. A has the ball, which is equals to 0.25. And probability of B has the ball will become 0.25, and for probability of C is having the ball with him after 3 throws, which is equals to 0.5. So in this way, by considering the transition probability matrix, we are going to find the probabilities for each and every person, that is A, B and C, that is 3 boys. Now let us see one more problem where we are given with the transition probability matrix. Here transition probability matrix of market share of 3 lands ABC, it is given by this transition probability matrix. Here initial market shares of 3 bands are given. That means we are having the P to the power of 0, which is equal to 0.3, 0.3 and again 0.4. This is the initial probability matrix which is already given in the question. Now we need to find the market share in the second period. So here let us write the given data where we are given with the transition probability matrix, which is 0.2, 0.4, 0.4, 0.7, 0.2, 0.1, again 0.3, 0.3 and 0.4. This is the transition probability matrix which is already given in the question. Now P to the power of 0, which is nothing but the initial probability matrix, which is again given 0.3, 0.3 and 0.4. Here we are converting the percentages into decimals, because in the question we are given with 30%, 30% and 40%. Now we need to find the market share in the second period. That means this is nothing but P. Second period is nothing but, it is the 2-step probability matrix. That means it becomes P square. So we are going to find the value of P square from P. That means 0.44, 0.28, 0.28, 0.31, 0.35, 0.34, then the last row 0.39, 0.3 and 0.31. Now in the second period we are going to take it as in the same way P to the power of 0 into P square, because if we multiply this initial matrix with p square, then you will get the market share in the second period. Now, let us multiply, which is equal to 0.3, 0.3 and 0.4. And the value of p square will become 0.44, 0.28, 0.31, 0.35 and 0.34. And coming to the last row, which is equal to 0.39, 0.3 and the last element is 0.31. So if you multiply these two matrices, then you will get it as 0.381, 0.309, 0.31. So this is the probability of the market share in the second period. In the question we are given with the second period, so which is equals to p to the power of 0 and p square. So the value of the probability of the market share in the second period is this much. If in case in the question it is given for the third share or it is given for the third period, then we are going to find the p cube because it is the third step transition probability. So we are going to find the p cube. Then if you multiply the initial probability with the 3 cube, then you will get the third period probability of market share in the third period. In the same way, if it is given for the fourth, we are going to find out p power 4. If it is given for the fifth period, we are going to find p to the power of 5 and so on. So in this way, using the nth step probability, nth step transition probability, we are going to find all these values, or we are going to find all the probabilities which are given in the question. Here for third period, we are going with a third step transition probability. Here in the question it is given as second period. So it is second step transition probability. So in this way we are going to solve these problems, and these two problems are the most important problems which are the repeated questions in our external exams. Thank you for watching the video.